Hello, welcome to Unit 11 on Statistics. We are going to start today with Day 1, Introduction to Statistics. So we're going to talk about some vocabulary and something called central tendencies. Statistics is the study of numerical data or information. This data, the collections of related numerical information, it could be anything from sports scores, election results, grocery sales, it could be ages, it could be weights, and we're going to talk about two different ways to classify this data. But there are three typical steps in a statistical study, and the first step is just how you go about collecting your data, so the collection of data. Once you have your data collected, it could be surveys, it could be polls, it could be just literally gathering data like from a test that was given of some sort. Once you have it collected, you then have to organize it. So this is the organization of the data into tables, charts, and graphs. We're going to be organizing our data in a bunch of different ways in this unit. We are going to start off with box and whisker plots, then we're going to move on to dot plots. We're going to do some histograms, frequency histograms. We might do some, or we will be doing some two-way tables and Venn diagrams. There are so many different ways that you can organize your data once you have it collected. And then once you have your data, you have it organized, and you have it in a table, a chart, a graph of some sort, what you can then go ahead and do is draw some conclusions from your data. You might see some tendencies, things that are more likely or less likely, and then that allows you to predict future trends. So predict future trends and future events based on the analysis of data. And there's two main different types of data that we're going to focus on, and that's qualitative versus quantitative. Qualitative, otherwise known as categorical, are things that fit into categories. So I'm going to write categorical because think of it as like qualities. That's like the root word of qualitative, or the qualities. So you could organize things by color, gender, flavor, type of brand. It could be like type of cereal brand, type of car, color of car. So anything that can kind of fit into a category. The other type that we're going to actually start our unit off with is quantitative. So that's a numerical value, thinking quantitative or quantity. And that is going to be more of your numbers. So that says quantity, by the way. So that's going to be more like your scores, your ages, your heights, your weights, that sort of thing. So what I would normally do if I was there, I would have you read these 12 different options, and I would have give you about a minute, and I would like you to circle all of the ones that you think are categorical, that would fit into a category. So I'll pause here if you want to pause the video, take a look at these 12 outcomes. Okay, so hopefully you got a chance to take a look. Categorical data, remember, you want to fit into a category. So anything to do with numbers, we're not going to pick. So a person's eye color, that's definitely categorical. Height, unfortunately, is a number. Age is a number. Weight is a number. But type of sports they might play, that's definitely a category. A distance that's thrown, that's a number. Outcomes when tossing a fair coin. That's actually a really good one. So if you toss a coin, and it's called a fair coin, then that means one side is heads and one side is tails. When you toss it, your outcomes are either heads or tails. So those are actually two different categories that you could get, so heads or tails. And then the last one that I see here is flavors of ice cream would be the last category that we could fit into. Now, when you're collecting data, like if I walked around and I tried to survey, you know, how many people have blue eyes in a Walmart, When data is collected, it is usually taken from a small part of a population. That small part is going to be called the sample. So let's say I ask every 5th person that walks into Walmart what their eye color is, and I make a little tally, or I make a little list of all the different colors that I get. Now, if somehow I'm able to ask every single person in an entire population what their eye color is, that's considered a census. If only I could spell right. There we go. That's considered a census or a population. So most often we're dealing with samples of a population. So samples are very useful since the results obtained from a small group, so a sample group, can be studied to make generalizations about an entire population. So my example of, asking every 5th person walking into Walmart what their eye color is, that is a sample. But once I get my whole sample from a whole day of asking people going in and out of Walmart their eye color, I can say, well, this is the outcome I got at Walmart. I can kind of say, well, then our entire, town or city probably has a similar ratio in those eye color outcomes. But we do have to worry about something called bias. Samples need to be chosen carefully to avoid bias. Bias is a tendency to influence the sort of outcome of something. So to influence the selection of certain members of a population, which sometimes produces unreliable conclusions about a population. So that could be, we'll see an example in a little bit. It'll say something like, I want to get an average height size of the junior class, but I only ask, or how about just let's say the high school. I want the average height of a high schooler, but I only ask the basketball team their heights. That would be introducing bias because most likely if they're on the basketball team, they're probably slightly taller than the average high schooler. So just little things like that. A sample must fairly represent an entire population being studied. Here's another one. For example, the sample for the study of residents' satisfaction with the local park should represent all people in the neighborhood, not just those people who use the park or come to it on the weekends. People dissatisfied with the park may not visit it at all, but they should still be included if we're taking the opinions of all people in the population. Another thing that could persuade or change the outcome of certain studies is how many people you're asking. If you're only asking 3 to 4 people, or those 3 to 4 people that you ask are like your friends or something like that, they're going to decide that that's not a sufficient amount of data that was being collected. So you want to ask a large amount of people from varying backgrounds. So what that means is you want it to be as randomized as possible. So a sample should be large and random to avoid any bias as possible. Now, an experiment is slightly different. An experiment is not something about surveying or asking or anything like that. An experiment is where you impose a treatment on one or more groups. Usually you have a treatment group, and then another group is what we call the control group, and the control group doesn't receive any treatment. So sometimes while you're testing, let's say, the effectiveness of maybe a new drug or something like that, people are going to come sort of do this experiment to test the new drug. They come in and they're basically randomly split into 2 or 3 groups. But let's just focus on the 2 for right now. If I take a group of people and I split them into 2 groups at random, one group might receive an actual treatment for their blood pressure, and the other group might still be taking some sort of pill, but it's usually like a sugar pill or a fake medication that makes them think they're receiving a blood pressure medication. And if the subjects that are in that treatment group that technically aren't receiving any medication feel like they're getting their blood pressure is getting better or something like that. We call that the placebo effect. So these next 4 examples here are just sort of asking you if you can decide if there's bias introduced into their study or not. So number 1 says, your teacher is selecting students to help set up for a dance. Only 5 students are needed, so she puts everyone's name in the hat and selects 5 names without looking. Sounds pretty randomized to me, so I would say that there is no bias for this example. No bias introduced there. She did it at random. She wasn't looking. She didn't pick her, 5 favorite students or the top 5 in the class or anything like that. Just everyone had an equal chance. Number 2, you want to know how many students in our school have a broken bone, so you only ask people on the football team. That sounds like it's kind of biased to me, because I would think if you're on the football team, you probably have a few broken bones in your lifetime. Number 3, you randomly chose 50 books from the school library to find the average length of each book. Randomly chose, I like it, 50 books, that's a lot, so I'm going to say no bias on that one. And last but not least, a bank casually selects customers throughout the day to ask them if they are pleased with the service they receive. The fact that they're casually selecting people and not randomly selecting people, and they're specifically asking if they're pleased with the service, they're probably only going to ask the people, casually ask the people that they know are happy customers, so we're going to go that there's definitely bias on that one. Okay, well, when dealing with quantitative data, we are going to do something that you might have done in middle school at some point, and we are going to talk about mean, median, and mode, which we are going to call our central tendencies. Mean, or the word average. The mean or the average of the set of data is when you add up all of the numbers and divide by how many numbers that you just added. So for example, 3 consecutive integers can be represented by x, x plus 1, and x plus 2, and their average is a 22. What are those 3 integers? Now you might be able to figure it out off the top of your head, but I'm going to show you how you would set it up. So if we consider these 3 separate integers, the first one plus the second one plus the third one. Since we added 3 numbers together, we would divide by 3. If we were adding 5 numbers together, we would divide by 5, and so on. And they're telling me that the average equals 22. So I'm going to set it equal to 22. Well, in the numerator, I can combine like terms to get 3x plus 3. And if I kind of try to conserve some space here and I cross multiply, I'm going to set that equal to 66. Subtract 3 to the other side, divide by 3, and I get x equals 21. So what are the 3 integers that would average out to a 22? My 3 consecutive integers would be 21, 22, and 23. Now you may have thought of that off the top of your head, but this is how you would find the average by hand for anything if needed. The median is what we consider the middle data point. So it has to be arranged in numerical order. So as long as it's in numerical order, we can pick the middle. If there are 2 middle numbers, then you're just going to take the average of those 2 middle numbers to find the middle point if there are 2 that fall in the middle. The mode, you might remember this one. Is the one that appears the most often. So if there are multiple modes, like if a number repeats the most often, we pick that one. If there is no numbers that repeat, then we have to write the word no mode, not 0, because 0 is considered a data value. Range. Range is basically the highest minus the lowest data set, so that is the difference. That is the difference between the greatest and the least value in the data set. So the maximum minus the minimum. And then you might also remember this vocabulary word, or the quartiles. Quartiles have a nice root word in there like quart, so it's going to divide the data into 4 equal parts, which we'll see a little bit more about tomorrow. And then once we have our 4 equal parts, there's something called an upper quartile and a lower quartile, otherwise known as quartile 3. That's your upper quartile, and quartile 1 is your lower quartile. And so when I'm trying to find the IQR, that's going to be the upper minus the lower, or Q3 minus Q1. All right, so this is where we're going to have to introduce our calculator into today. Try and stick with me. If you need to rewind the video, you can absolutely rewind the video so you can see what calculator buttons I'm pressing. But we're going to have our calculator do the hard work for us that you used to have to do by hand in the middle school. So obviously I have all of the calculator steps listed out right here, so feel free to refer to those as needed. But it says for the following data set, we're going to use our calculator to find the mean, the median, the mode, the range, the quartiles, and then we'll calculate the range and the IQR and things like that. So if you guys could grab your calculators, I'm going to bring mine up right now. Pretty fancy, I know. And what we want to do is we want to input this data. So if I read the instructions here, it says access the stat menu by pressing the button stat. Oh, fancy that. It's right here. It says stat. So I'm going to click on that button. So hopefully it takes you to this list. And it says choose option 1, edit. So I'm going to hit enter so I can edit my list. Now I don't have anything in my list. But if I did have numbers in my list, what you would want to do is arrow up so that L1 is sort of darkened in. Press clear and then hit enter, and that should wipe out any digits or values that are in that list 1. You would have to do the same thing for L2 if there's anything in L2 and so on. So now that I have my list clear, in this column where that black bar is, I'm going to type my first data value, which in my list here is a 5. So I'm going to type 5 and then an enter, and that should put the 5 in that spot. Then 7, 13, and then 6, let's see if I can use these, 6, 8, 12, 17, 20, 6, and 17, enter. Okay, so I have all my digits typed in L1. I am now on step 4, step 3 again. Step 3, press stat. Then it says to arrow over to calculate, so I'm going to use my right arrow key to head over to calculate. And we actually are going to pick option 1, so hit enter. And this screen should pop up and it says list L1. List L1, that's exactly where we put our list, so we're all good. If your calculator has anything right here where it says frequency list, you're going to want to clear that out. So if you go down to frequency list and there's something there, please hit clear, arrow down one more time to where it says calculate, and hit enter in your calculator, and it gives us this beautiful list. Now it's going to be kind of hard for me to sort of toggle back and forth, but that very first one, that X bar that says 11.1, that is your mean. Your mean is, so that's my X bar, I'm going to write that little symbol down, X bar was 11.1. But there's more information than just what's on this, so that's pretty much the only number we're really going to care about so much on this list. But if you could take your arrow key and arrow down, 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 there's actually a second hidden list that this screen has. So now that I arrow down, you can see where it says minimum, Q1, median, Q3, and maximum. And that's exactly what we're going to fill in for these spots right here. So our minimum is 5. Our Q1 was 6. It said median was 10. Our Q3 was 17, and our maximum was 20. And actually, Q2 and median are the same thing, so I'm going to put the 10 in both of those places. Now when I'm looking at these numbers, even though they're not in numerical order, I have 2 6s I have 2 17s, and I think that's it as far as repeats. So I would have 6 and 17 listed as my mode. My range is my maximum value, which is 20, minus the minimum value, which is 15. And my IQR is Q3, which was 17, minus Q1, which would make 11. So we're going to practice that one more time now that we have one of these examples under our belt. We're going to practice it with these numbers to the right. So repeat all the same steps. Stat, enter, arrow up, clear, enter, so that I can clear out that whole list. And I'm going to type in our new digits. So 30, 35, 40, 45, 50, 55, and then bam, 100. Oh, I do have a typo. Let me go back up to that. Let's see if it'll let me edit. I just want to override it with a 45. So 45, enter. Okay. Stat again, arrow over to calculate, option 1, hit enter, still list L1, go down to calculate, and we can fill in all of our missing values, so our mean and everything else. It's 50.7. All right, so 50.7 is my mean, my min, my Q1, my Q2 is the same thing as my median. Ooh, that should be a 45, huh? I was saying Q2 and wrote a 2. Q2, Q3, and then my maximum 100. Any duplicates on this one? I don't see any mode, none. My range is my maximum minus my minimum. My IQR is my Q3 minus my Q1. All right, cool. All right, so looking at those values that we just got from letter B there, it says looking at those same data values, if these numbers represented the number of miles driven to and from work each week, would it be appropriate to use the average to describe the data set, or maybe something else? So there are two different ways that we can measure like the middle or the average center point. And I actually would say for this data that 45 is probably a better middle point than the mean, which is about 50. So I actually say the average is a little too high. I'm going to shorthand this. The average is a little too high. And the reason for that is because of the 100. Due to the outlier of 100. So I actually would say the median is a better measurement. And that happens when we have an outlier. So an outlier is a data value that is much greater than or much less than the other data values, and it sort of skews the data. And when I mean skew, that means it kind of like pushes the center of it off from actually being in the true center. So if that 100 was removed, actually it probably would put the mean and the median almost smack dab at the same spot. So if that 100 was removed, the mean and median would be located roughly in the same spot as each other, I should say, in the same spot. I'll put the word equal to each other. So that says equal to each other. So how can we identify an outlier? Sometimes it's super obvious, like 100 was a super obvious outlier, but other times it's not as obvious. And so what we might want to do is calculate that. And so one easy way to figure out if something is an outlier is if you figure out what the IQR is, the interquartile range, you multiply it by 1.5, and then what you do is you take that value and you either subtract it from Q1 or add it to Q3 and sort of figure out this like range of numbers. And if anything is below the lower end or above the upper end, we consider it an outlier, which we'll practice at the bottom of the page in just a second. One last little thing before we do some practice problems. So if I take a set of data, such as 4, 5, 5, 6 here, the reason why I picked these numbers is because I think it's very obvious that the mean, the median, and the mode are all 5. 5 would be the middle, 5 would be the average, and 5 would be the one that repeats the most often. But if I were to add 10 onto each of their values, if I add 10 onto each one, it would become 14, 15, 15, 15, 16. My mean, my median, and my mode would all be 15 now. If I multiply each of these data sets by 10, so if I multiply them by 10, instead of adding by 10, it becomes 40, 50, 50, 50, 60. Now the average, the median, and the mode are all now 50s. So if a constant is added or subtracted to each data set, then all three things are going to increase or decrease, depending on what you did, by that amount. So whatever you added, add on to the mean, the median, and the mode. If a data set is multiplied by a constant, then the mean, median, and mode are also multiplied by that constant. So if somebody manipulates a set of data after the fact by adding something onto all the digits or multiplying by something onto all the digits, then you don't have to recalculate anything. You can literally just either multiply or add onto the mean, the median, or the mode. Okay, so given the following data set, it says which of the following statements is true. So because it's discussing any outliers, we need to type in the data into our list again. So stat edit, I've already typed in that data, so that means I need to go to stat, arrow over to calculate, option 1, hit enter, scroll down so we can figure out our Q1 and our Q3. So my Q1 is 10 and my Q3 is 26. So Q1 is 10 and Q3 is 26. For me to be able to calculate an outlier, I need to first find the IQR. So the IQR is Q3 minus Q1, which is 16. But then I need to do 1.5 times that value, which makes a 24. I need to subtract that from the Q1. So Q1 was 10 minus 24 is negative 14. And then I have to add it onto Q3. So 26 plus 24 is 50. And if there are any numbers that are either lower than negative 14 or higher than 50, then we can say that there's an outlier, and there is one number that is bigger than 50, so therefore there is only one outlier. Number 2, it says, given the following data set, is there an outlier for this? And what is it if so? So again, we would have to type these into our list in our calculator. If you want to pause and try this one, maybe you can. I have to type in my digits. It's not very streamlined when I don't have an actual calculator in front of me. Okay, so I got all my digits in, hopefully. Stat, calc, option 1, pop, pop, pop. I need Q1 and Q3. Q1 is 6, Q3 is 17. Q1 is 6, Q3 is 17. I need to find the interquartile range first. Then I multiply that by 1.5. And I get 16.5. And then I subtract that from Q1 and get my lower bound, and then I add it to Q3 to get my upper bound. So anything between negative 0.5 and 33.5. So after all that, doesn't look like there are any outliers. All right, last but not least, the temperature is recorded in Exton at noon for 2 weeks, are as follows. Is there an outlier, and what is it if so? So I'm just going to pretend that we typed this all in our calculator and we got some data values and whatnot. And I'm just going to tell you that our Q1 is 75 and our Q3 comes out to be 80.5. So given that that's our Q1 and our Q3, we need to find our interquartile range. So 80.5 minus 75 has an interquartile range of 5.5. I multiply that by 1.5. Subtract that from the Q1. Add it to your Q3. To get your span of numbers, it looks like it's going to go from 66.75 to an upper of 88.75. And if anything falls outside of that, which I believe there's one, 49 would be an outlier because it's not between those upper and lower numbers. So 49 is an outlier. Okay, thank you.